Hello, YouTube watchers, listeners, students, colleagues, and friends. This is Dr. Satish Sengal, PhD, Faculty Computer Science, El Camino College, Torrance, California. Today I'm going to talk about a linear search function for array of classes. Linear search function for simple array like integers, characters, floating points. Those are pretty easy. We're not going to talk about those. Uh, Classes have multiple members, and you may want to search an array of classes based on a particular field. That's why this problem is more interesting. So let's go. Array of classes can be searched based on any of the class data members or field. Consider, for example, the class student below, class student. There are two fields here, string, first name and last name, ID and GPA. And then after that, class is going to have public functions and constructors. In this type of class, for example, we may search an array of student class either based on ID or based on last name. Generally, nobody searches on first name and GPA because there might be too many duplicate values. ID could be unique, so searching based on ID would probably make the most sense. And last name, although not unique, but you could search with the last name. In a better search function, you could return all the values that are found with the same last name. Okay, so the key could contain either the last name or ID, and key is the one that we're going to search inside the array. Okay, first I want to show you the mechanism of linear search using an integer array, and that would be shown through a linear search Java applet. Let me actually click on that, and the applet is going to show. So here we have option of linear search. I'm only going to talk about linear search. Let me decrease the animation speed so you can see what I'm doing. So let's say I'm looking for a value of 144 in the array. Array of course is visible to me, but assume that you can see the array, which you will not be able to when array is stored in the RAM. And we are looking for the linear value 144. We're looking for the fact whether it's there, and if it's there, at what array index it would be there. This is my array, 0 index 1, 2, 3, all the way up to 31. And we could have done with a smaller array, but that's okay. I'm just going to live with that. And wherever 144 is found, that index will be shown here. Okay. So this is how linear search works. I'm looking for this key. Key is 144. So first, I'm going to compare with this one. Okay, I guess I have to reduce the animation to very small. Let's start it again. Okay, pause. Okay, animation paused. Skip back. Animation completed. Okay, let me play it again. So what I'm going to do this time, let me actually refresh it so I can start from the beginning. Okay, there we go. So I think I should go with this step for a while. So same thing, this time I'm gonna, let's say, search for value 186. 186. Okay, and I think I can start this and pause immediately. Okay, so 86, which is the key, is being compared with the first element in index 0, 25. There's no match. So now I step forward. Now it's gonna, I've already crossed the index. I'm at the index 1 now. Now I'm gonna compare key 86 with 37, and there's no match. So I'll keep stepping forward. See, there's no match. So step forward. Now I'm gonna compare with the value at index 2 with the key of 186, and again there's no match. So if I step forward, this time I'm going to compare 93, which is the index 3, with the key at 186. There's no match. So I step forward again. This time I'm going to compare value 117 at index of 4 compared with the key 186. There's no match. So I step forward again, and this time I'm going to compare value in the array 122 at index 5 with the key 186. There is no match. And then step forward. This time 184 is being compared with the key 186 at index of 6. There is no match. And finally we found a match. The value in the array at index 7 and key is the same. So we found the match, and the result would be that index at 7, the element has been found. Okay? So that's how linear search works. If it was not there, and I'm just going to show that in the animation, then it will not be found. So let me just skip back. Let me just start this again. And this time I'm going to look for a negative value because all values are positive. Or also you can see that this array is sorted. It doesn't have to be sorted for the linear search, but it is sorted because they wanted to show binary search at the same time. Well, actually, put large. Okay, that's the large array. We don't want large array. Okay. So let's say I want largest value is 1960, smallest value is 26. Let's say I want a value of 5. And I'm going to increase the animation speed so you can see it real quick. It's not going to find it actually. So let's go. And it says element was not found and a -1 index is returned. They could say that because it was sorted. Okay, so let's try another value. Let's say 2000. And linear search. Now this time it's going to compare all of them actually. See? And it's not going to find it. And it didn't find it. So it should still give a result here, -1. Surprisingly, it didn't. It reached index 32. So when it doesn't find, it should return index of -1. So that's the whole idea. We are going to write our code based on those principles. Okay, back to PowerPoint. Okay, these are the conclusions from Java Applet. In linear search, the keys match linearly with each element in the array, as arrays iterated from low subscript to high subscript. You remember that we started with 0 subscript and kept comparing elements in the array with the key as we progress towards higher and higher value of the subscript. If key is found, then the index at which key is found can be returned. And the process is similar for searching an array of classes, but there's one difference, that search function is passed an object of the class that contains the key to be searched, and in addition a flag is passed to the search function that whose value would control the basis for search. So we can say flag equal to 1, search for ID, flag equal to 2, search for last name. Okay, that's the conclusion from Java Applet. All right. Okay, so what kind of function prototype would be there when we want to search array of student class? The function prototype will look like this. Bool is the return type, linear search is the name. It will take array of student as an argument and a key which might contain either the ID we're looking for or a last name we're looking for. and logical length of the array, which is int type. And then since index where the key is found must be returned, and normally unless we use special techniques like returning through a tuple, you can only return one value by the return mechanism. So therefore the index where key will be found is written by reference. When a value is passed by reference, incoming value would have incoming would be blank or not useful, but returning value will be where key will be found. And then the flag, which will determine whether, which will control whether we are searching for ID or last name. So this function actually does a double duty. Duty number one is that it returns by return mechanism a Boolean value of true if the function argument, which is key, is found in the array. Otherwise function returns a false. And duty number two is that it returns the index where found by reference. This variable is populated. So if it is found, it will return a 0 to some other higher positive value index. Otherwise it will return a -1 for index where found. And now you can appreciate, based on your knowledge of arrays, that -1 is an impossible value for the array index. Okay, so that's what this function does. Okay, now we're going to code this function, linear search function, in Xcode. And first I'm going to show you only the code of the linear search function, and then I will show you its execution in the main function. Okay, so we're done with the PowerPoint. We won't come back to the PowerPoint. And let's look at our linear search function. It's right here. Takes the array of student class, a student key, which could contain either ID or last name. Could contain more than that, but it will be enough that it contains the ID that we are looking for or last name we're looking for. Logical length of the array. Index where found will be 0 or higher if this key is found in this array. Otherwise it will be set to -1. And flag will control whether in this key we are searching based on ID or last name. So since a Boolean has to be returned, we declare a Boolean variable found and set it to false. Okay. And then since we know that if not found this should be negative, I set the index where found to -1. Now do not leave this without setting -1. You cannot depend. Functions have to work independent of whatever goes on in main function. It is function's responsibility to make sure that correct value is returned. So it must be set to -1 here. Okay. So we need to iterate array through its entire logical length. So we start I equal to 0, I less than logical, and I plus plus. Okay. We have set it arbitrarily that if flag equal to 1, then we're going to base search on ID. And then we get the ID from the key. This key contains the ID we're searching for. And from each element in the array, as iteration goes through, we get the ID. If there is a match, if in certain array element I find the same ID that is contained in the key, then I found the match. That means the key is there in the array, and the found that was set to false, I set that to true. An index where found that was set to -1 set to I. I is the index which I'm iterating at that particular time. So if it's not found in 0, then this will not be true. So this whole thing will not execute. And this loop and this if statement together control the iteration through the loop. Okay. As soon as there is a match, we set the found to true and index where found to I where it was found. So this value will go back to the main function by return, reference return. Okay. And then I return the found by return mechanism, because function is supposed to return a boolean. Okay. Flag 2 is search based on the last name. In order to do case insensitive search, I will get two strings, nm1, where I will get the last name at the array index I, which is being iterated at a certain point in the iteration loop, and then nm2, get the last name from the key, and they need to be capitalized in order to do a case insensitive search. I'm not going to explain this capitalization mechanism using the C++11 enhanced for loop right now, but this loop will capitalize nm1 and this loop will capitalize nm2. I'll do that in some other video. And once again, if nm1 equals nm2, that means there is a match in the name, last name inside the key, and last name inside the array. Okay, and then I set the found to true and index where found to my I, where the match was found. Now understand this, if ID could be duplicate, or if name could be duplicate, this search function is only going to return the first match. It's not going to return all the matches. For that, we will have to actually return an array. Okay, which again will have to be passed by reference to the function. So we're not actually doing that case. We should do that case in more advanced application, but right now we're not doing that. Okay, we are only returning the first match, so just remember that. Okay, so if you didn't understand something in this function, go back in the video and watch it until you understand it. Okay, that's my linear search. Now I'm going to go and see how it's applied using the main function. Okay, so in main function, I have a loop, flag control loop, done equal to false, not done will be true. And then I ask user enter 1 to search for ID, and 2 search based for the last name, and 3 to exit. Okay, I'm only going to explain one choice, other would be identified. Okay, imagine they want to search based on ID, and they enter 1. So if choice is 1, then I ask user to enter ID to be searched, and ID is an int, so that will be whole number only, and I take the input for that. Now to build a student key, I'll call the constructor and only populate the ID field that I just got from the user here. Others can be given default values. This is totally normal. There's nothing abnormal in preparing a student object in which only ID field is populated. So just remember that. There's nothing abnormal with this. This is perfectly normal. This is done in software engineering all the time. Okay? And then, since linear search function will have a reference return for the index where temp could be found, I set the index to 0 and I pass that. So if you remember the arguments, the first argument is the array, which was populated by some function here. Yeah, this is, I'm not exposing this code, but array is actually populated here somewhere, sorted, printed, and all that. All that. And then temp is the key we are looking for. Logical is the array length, and the reason I have to cast into int type, logical is actually size t type. I need to cast to int, otherwise I'll get a warning. And index is again int type, and flag is 1 because I'm searching based on ID, because I got the ID here, so I need to search based on that. Now this function will return a value true or false, so boolean found will be either true or false. Okay, so if it is found, I can have two situations, either it's found and it's not found. Either found is true or it's false. So if it is true, I execute one piece of code. If it is false, then else block will execute, and I say student ID was not found. Okay, let's see if found is true. What to do? Then I can tell user with confidence that student with ID, whatever they entered here, is found, and then we can print the full record because we got the index. This index populated by the index where student is actually located in the array, and we have print function in the class that can print a student, and we get that array index where a student is located, call the print function to print it. You'll see execution of that in a minute. And similar happens, choice number 2, when name is searched, code is identical. I will expose the code but will not go through it because explanation is identical. We get the last name, we create the temporary student, we make the function call to linear search. If it is found, we print the whole record. Otherwise, say student with last name, L name was not found. Okay. So I'll expose the code for a minute and you can understand it. Or you can pause the video and look at the code in more detail. Okay. We're going to run it now. Stop it. And then I do believe I have a terminal open here, and I can drag and drop that here. Path to the input file, I have copied that here somewhere. Could have drag and dropped that, but that's fine. Paste. And there's just sorting going on. Now it came back with the dialogues that enter 1 for ID search, enter 2 for last name. And I'm looking at the IDs here, ID 1, 2, 3, 4. So first I enter 1, then ID 1, 2, 3, 4. And it was found, had to be found. It's right here, John Doe. And John Doe ID 1, 2, 3, 4, GPA 3.2. But if you look at the ID, there's no ID with -1. So I can just search again. And I can put an ID of -1. And it says ID with -1 was not found. I can do the search, name search also. Last name Zach. And you will see the case insensitive search will work too. The ACK. All the stored name is with uppercase Z, but I'm entering the lowercase. And it says student last name Zach was found. That's the full record. And if I enter something like XYZ, there's no name XYZ, it'll say student with last name XYZ was not found. And if we do 3 exit, we'll exit the program. So that's the linear search on array of classes. Okay. Please watch the video again if you didn't understand any portions, and best wishes to you. Thank you.